Hello, keep in mind that you have to learn the vertebra of the skeleton, and they're made up of these bones that you're seeing here. This is an example of the 5 lumbar regions. This is an example of one of the thoracic vertebra. There are 12 total. And then this is cervical, and cervical has 7 bones in it. The problem is that only C3 to C7 look like this. They have a generic form, but C1, this one, and C2, the one with sort of this little process called the dens or the odontoid process, these follow their own rules. But when we look at these words, usually you can use the same vocab words on all of them. So let's get started with that. Here is our body of the vertebra. Here is our body. Here is our body. So you can see how easy it is to identify the body on all of them. And typically this is even how you can tell which vertebra is which. You should know that the lumbar one from class, that this is going to withstand most of your body weight. It has to have larger bodies for a nice little intervertebral disc to help withstand a lot of downward compression. And the thoracic is responsible for holding our rib cage. It doesn't really need a huge body, but it needs these unique transverse processes. And so when we look now at this one doesn't need, because your neck shouldn't be supporting, it only has to support your skull, not your entire weight, so it's a small little body. Next term, you'll notice on the posterior end, right, because this is anterior, the body is always anterior or towards the front of the body. And so towards the posterior part of the body, or the posterior part of these vertebrae, you have your spinous process, and spinous process. You can see they all sort of share that same property. And then next we have our transverse process. This is going to be a process that goes from the center and goes lateral. It goes towards the sides of the body. And so if we look at this structure, that's very similar. It even has the same name, transverse process. But what makes it different is that this is going to serve as a site for rib attachment. If you can remember, right, if we're looking at our skeleton has 12 rib pairs. And so all those linkages are linked to the thoracic. So I always know I'm looking at the thoracic vertebra just by looking at the ribs. And so you can see lumbar is the largest one that comes down here. But otherwise, back to this, you can see that if you go to the very back end here, that transverse process that we just saw in the vertebra that was taken apart is holding onto a rib. And so that's what makes the transverse process unique in the actual thoracic bone, because in the thoracic bone, these are responsible for a rib attachment site. Lumbar, it's not. This is where you have muscle attached, but we don't care about that. Today we're talking about bones. And so this is our cervical now, and this is a cervical bone that also has transverse processes, but it's these little rims here. They actually, instead of going out to the sides like these two, they actually go and wrap around forward and then end up making these tiny little holes called transverse foramen. That's why they're called that, because this transverse process folds in, connects to the body, and creates a transverse foramen. Next, you'll notice that each and every single one of them have an opening in the side here, or an opening in the middle, pardon. That is going to be called the vertebral foramen. This vertebral foramen is going to allow the spinal cord to come from the brain all the way down through all the vertebrae. And so with that, now, when we think about how these bones attach, these bones will meet a bone above and a bone below. And so if we think about that concept, I'm grabbing 2 thoracic right here. You can see that they're going to have to find a way to attach with each other, right? Because one bone this is just one vertebra, and it's made up of 12 of these. So how do they connect together, right? Like, how do they connect? And so you'll notice that you have these little segments here. They look like the little flattens. I always sort of like to cheat and sort of look at this, and it sort of looks like a giraffe's face to me. And so if you look at these little top horns here, they're like flat and a little sharp. That's going to be a site of attachment for the bone above. Can you see how those are connecting there? Do you see that? And so that is going to be how they articulate is the proper term. Let that term remind you of the name of the structure. This top one here is these two, 1 and 2, is the superior articular process, and facet. So you only have to know the process, which means that this is going to be the superior articular process. Superior articular process. Now we think about it on the other end, right? This one has to not use the top ones, right? The ones on top. It has to use the attachment sites here. And so again, if we look at our little giraffe, we were looking at these little horns for the first one, superior articular process. But if we look down here and you pinch the cheeks of your giraffe, you are finding the inferior articular facet and the inferior articular process. And so that's how they meet with each other, and they're able to sort of combine like that. And so when we examine these vertebrae here, you can see these vertebrae are going to be slightly different from the generic cervical vertebra. They're a little different, but they have a lot of things in common. For example, they all have transverse foramen. You can see all of them have these little openings here, transverse foramen, and transverse foramen. And when you look at them, you can see that C1 and C2 are really missing a profound spinous process. They may have one, but it's not necessarily, actually this one might be a little chipped, but it's more longer on the rest of them. But what makes C2 now distinct, this is, the whole bone is called axis. And yes, it is like C2, but it has a nickname, axis. And here you can see this is the odontoid process of your list. This is the only structure you actually have to know in this bone. There are others, but this is the only one that matters. And so this is the odontoid process, and you can always see it has like a little thumbs up. I always think about it, or like someone's about to give you a hug, right? Do you see it? But anywho. And then now when you look at this one, this is going to be our C1. This is going to be the first bone, and it is nicknamed Atlas. It is nicknamed Atlas because it's holding the skull, and just like the Titan Atlas that was condemned by the gods to hold the whole world on his back, we have our little C1 condemned to hold our skull up for all of eternity, or until we're no longer alive. But otherwise, that's the point of C1. And so C1, you can always tell you're looking at it because it doesn't have a body. Right? Even where the odontoid process needs like a site to attach. But look at this one, nothing. Just a huge vertebral foramen, an opening that's allowing the spinal cord to go from C1 all the way down through all the key little players here, all of our bones. And so altogether, that's going to be the vertebra.